Giant Earth-like planets orbiting in distant solar systems may contain exotic compounds that should, in theory, be impossible under the rules of classic chemistry. Researchers said the extreme pressures that exist in the interior of these so-called super-Earths, which are many times heavier than our own planet, could create new chemicals. Furthermore, these may give these planets powerful magnetic fields that could protect them from cosmic radiation, making them more hospitable for life. The compounds, which are not thought to exist on Earth, could also help drive the circulation of heat far below the crust of these planets. Professor Artem Oganov, head of the Computational Materials Discovery Laboratory at the Moscow Institute of Physics and Technology, and his colleagues examined the occurrence of silicon, oxygen, and magnesium on Earth-like planets beyond our own solar system. The elements are among the most abundant on the Earth, making up much of the crust and mantle around an iron core. While only a handful of rocky Earth-like exoplanets have been discovered by astronomers, most have a mass several times greater than Earth. This suggests the pressure in the interior of these planets is huge, and this may result in some exotic compounds being formed. Computer modeling by Professor Oganov and his team revealed the magnesium, silicon, and oxygen inside these planets may combine to form huge molecules with many more oxygen atoms than they do on Earth, where MgSiO3 is the most common compound. Instead, they found the elements are most likely to create a compound called MgSi3012, which behaves like a metal, and MgSiO6. Professor Oganov said, their properties are very different from normal compounds of magnesium, oxygen, and silicon. Many of them are metals or semiconductors. This is important for generating magnetic fields on these planets. As planetary magnetic fields are produced by convection of electrically conductive planetary interiors, high conductivity could mean a significantly more powerful magnetic field. This could mean these planets may have conditions favorable to living organisms, because the magnetic field would protect the surface from being bombarded by cosmic radiation. The new compounds do not fit with the rules of conventional chemistry, where at lower pressures these compounds form substances that act as insulators or semiconductors. MgSiO3 is the most abundant compound in the interior of the Earth and acts as an insulator. However, super-Earths such as Gliese 832c and Kepler-10c are 5 and 17 times heavier than the Earth respectively. This would create pressures so intense within the interior of these worlds, they could be between 5 and 30 million atmospheres. The researchers, whose findings are published in the journal Scientific Reports, added that MgSiO3 would undergo some unusual decomposition reactions at these pressures. This could drive convection within the mantle of these planets and perhaps even produce unique forms of plate tectonics. This affects the boundaries of the layers in the mantle and their dynamics, said Professor Oganov. For example, an exothermic phase change speeds up the convection of the mantle and the heat transfer within the planet, and an endothermic transformation slows them down. This means that the speed of motion of lithospheric plates on the planet may be higher.